Okay. Hello guys. Thank you to everybody that is going ahead and watching this. We're going to take some time and we are going to review some concepts that you will see on your study guide. So I'm just going to go ahead and kind of make a quick run through for the study guide. So, first few questions, we're talking about density. So these are all concepts that we talked about in class and pretty much straight from your notes, right? So density is D equals M over V. So this is obviously density. This is mass, and this is volume, right? And we can go ahead and we can rearrange this equation. So we can arrange the D is equal to M over V equation. If we multiply by volume on both sides, we get density times volume is equal to mass. So this is equal to, oh, whoops. So density times volume is equal to mass. We can keep on rearranging this and we can divide by density on both sides, and volume is equal to mass over density. Equal to mass over density. Another way to go ahead and to get this equation is we can go ahead and we can use this triangle method. And again, the key to the triangle method is to always write down the triangle correctly. If you don't write it down correctly, you're not going to get the right equation, right? So DMV, if I'm looking for mass, I would cover up the M, and then you get D times V because it's a cross. If you are looking for volume, you would go ahead and you cover up the V and you get M over D, so M divided by D, and that's what you would get for volume. So that is how you would go ahead and that is how you would solve that. So another thing that you would go ahead and to do is some example problems. So we will go ahead and we will solve this. So what is the density of a mass of an object that has a mass of 25 and a volume of 15? So this one is the same equation. We're going to go D is equal to M over V. I have a mass of 25 grams and a volume of 15 milliliters. I'm going to simply go ahead and divide 25 divided by 15, and you should get 1.67 grams per milliliter, right? So that is what you should get on there. And again, I just take the units and I put them on top of each other, and then that's what I would get. Okay, the next one is what is the mass of an object with a density of 15 grams per centimeters cubed and a volume of 6 centimeters cubed? So I am going to go ahead and I'm going to use my other equation. So this one is going to be mass is equal to density times volume. So in this case, it's going to be 15 grams per centimeters. Let me write it this way. 15 grams per centimeters cubed. And I'm going to multiply that by 6 centimeters cubed. I see that my units cancel. So then all I'm going to do is I'm going to go 15 times 6, and I would get 90 grams. Okay, next one. What is the volume of an object with a mass of 12 and a density of 5 grams per milliliter? So I'm going to just scooch that down over here so I have a little bit more room. So as I went ahead and I solved before, volume is equal to mass over density. I'm going to take my mass, which is 12 grams, and I'm going to divide it by 5 grams per milliliter. Then I am going to go ahead and I'm going to go ahead and divide that. And I should get volume is equal to 2.4 milliliters. And don't forget when you have, so this unit, grams do cancel, but it's because when you're dividing by a fraction, don't forget that you flip it, so it's milliliters. Okay, if an object has a mass of 2 grams and a volume, the volume given by the graduated cylinder, what is the density of the object? Okay, so we want to find, again, density is equal to mass over volume, right? And then what is happening here is that they give us the mass. So they say the mass is equal to 2 grams. The volume is whatever is happening in this picture, right? So that is going to be the volume. So they go ahead and they dunk this. I'm looking at this into, so it looks like for this one, it is at 0.3 milliliters. That is what we're starting with. And again, don't forget that you're measuring the meniscus, which is usually lower. And this is going to end up at 1.7 milliliters. So in order to get the volume, I'm going to subtract those two. So I'm going to get 1.7 minus 0.3, and I should get 1.4 milliliters. So my volume is equal to 1.4 milliliters. I'm going to go ahead and divide those. So I'm going to go 2 grams divided by 1.4 milliliters. And then that is equal to a density of 2 divided by 1.4. And that is 1.42 grams per milliliter. So that is what you would get for your density. Okay, so what are the different states of matter? So this one you should know. So this one we're just talking about having solids, liquids, and gases. So those are my 3 states of matter. So different ways that you can go ahead and you can change states of matter from one another. So this one just goes through the different vocabulary words. So we have, I'm just going to draw the diagram so that I make sure I don't miss any, and I have this right. So let's see, we have my solids, we have my liquids, and we have my gases. And again, all of these processes are reversible, right? So I can go one way there, and then I can go another way. So if I'm going from liquid to solid, that is called freezing. Let me zoom in so I have a little bit more room to write. If I'm going from gases to liquids, this is called condensation. If I'm going from solid to gas, this one is deposition. No, wrong one. Solids to gas is sublimation. And then I can also go the other way. So let me go ahead and let me color code this here. I can go from solids to liquids, and that is called melting. I can go from liquids to gases, and that is going to be evaporation. And I'm going to write that here because I'm out of room. And then I can go from gases to solids, and this one is called deposition. Right, so those are the different ways that your changing states can happen. So just remember that you can go ahead and you can change states, and this is all a process of adding. So you can add heat. So the green ones, we added heat. you can also take away heat, and that is how you can get from away from one process to another. Take away heat, right? So for the red ones, that is what happens when you take away heat. For so sublimation, all of that, that is how we take away heat. And then you can also go ahead and you can add heat. So you can add or take away heat, and that's how you get through these ones. I think I messed up here with the solids to gases. Let me see. Solids to, actually, let me look this up. Position. Position, chemistry. That is when we go from solid to vapor sublimation, gases to solid deposition. Okay, I got it right. I just wanted to double check. Okay, so other ways that you can change the state of matter besides temperature, you can also change pressure, and changing pressure will also force a phase change. So that is another thing to keep in mind, that changing pressure will force a phase change. Okay. How are temperature and the movement of molecules related? And what is this theory called? So this is actually the kinetic molecular theory. And I am going to go ahead and I'm going to use this graph to help me with the kinetic molecular theory. So basically, just by looking at this graph, as you add heat, right? So as you add heat, you get more molecule movement. Right, so as you add heat, your molecules are going to go ahead and those things are going to move faster. So that is pretty much what you see on here, right? And you see that temperature and where you're at phase change wise are related to each other. So as you add temperature, the molecules are going to move faster, right? So the slower your molecules, so the slower your molecules are, like the more slower the the slower the molecules are, right, the lower the temperature. So temperature and how fast the molecules move are related to each other. So I'm going to go through this phase change graph with you. This is obviously my solids, this is my liquids, and this is my gases. And again, you'll kind of see this. So as we add more heat and as the temperature goes up, we go from solids to liquids to gases. And we notice that these molecules are moving further and further apart from each other. So this is going to be like pretty much the same labeling that we saw back there. So we are going to go ahead and we're going to label this. So from solids to liquids, it is melting. From liquids to solid, it is freezing. From liquids to gases, we're going to go to evaporation. And from gases to liquids, that is condensation. So that is that graph right here. Okay. Next thing is to go ahead and to look at this pressure graph. So on the test, you will be asked to read a pressure graph and to be able to kind of determine where you would find solids, liquids, and gases. So pretty much all you have to do is to figure out a few points, right? So on the first question, they ask you, where do you expect to find a solid? So pretty much anywhere in this area, you would go ahead and you would find a solid. So you just have to go ahead and you have to pick a point in this area in which you would go ahead and you would find a solid. So if I wanted to, I'm going to go negative 150, and I can pretty much pick anywhere along negative 150 and I would get a solid. So I can say a negative 150 degrees Celsius and let's just say 1 atm. Yeah, atm. I would go ahead and I would find a solid. Another place I would find a solid is negative 210, right? That is another place. I can say that I would find a solid at, like, I can even say negative 175, right, which is somewhere in there, right? And then let's say like 12, right, which is like somewhere in here, and that could be like another place I go ahead and I find a solid. Okay, liquid. So liquid is going to be, again, any point in this area, right? So definitely um, any temperature that is pretty much over negative 100. So I'm going to say like negative 100 degrees Celsius and like 10 atms, and you'll see that I'm right in this area. You can also say like negative 50, right? Because that, and then if you put the pressure up to 100, that's another answer that you can get. So pretty much if you're able to point out a reasonable point in that area, you should be able to figure out if it's a solid, a liquid, or a gas. Sometimes they'll say vapor. Vapor means gas. So just kind of keep that in mind. Next one, we're going to go ahead and we're going to look at a point for a vapor. So again, it's going to be any point in here. And then I can say, I can go 0 or 1. I can go negative 50 again if I want to. I'm going to do negative 50 degrees Celsius, and now I can just pick I just have to be reasonable when I'm picking this. So I can say, if I say negative 50 and 10, that's right here, so that's one point I can say. I can say 0 and like 10, that's another point in which it would be a gas. I can also say negative 100 and like maybe 0.2 or 0.3, so I'd be like right over it. Those are all reasonable points. I'm going to say negative 50 and let's see. I'm going to say like negative 50 and 0.5 as a point that I can go ahead and find. Okay, and then the next question is, what state do you expect to find at negative 20 Celsius and 100 atm? So if I had negative 20 Celsius, which will be somewhere close in here, and 10 atm, so I would bring this across, and negative 20 is going to be somewhere in there. And so that one is definitely going to be a gas. So that is how I would go ahead, and that's how I would find my points. Okay, so this is some of the density graphs that you'll see, and on the quiz they will ask you if something is more or less dense. So this is kind of something that you are going to go ahead and to kind of look at. So it says, how is the density and the slope of a line related to each other? So remember that our density equation is density is equal to mass over volume. Your slope of a line, if you remember, is equal to rise over run. So basically, the density of an object is going to be equal to the slope, right? So density of whatever object you're talking about is equal to slope, right? The mass is equal to the rise, and the run is equal to the volume. So you'll see that both of those things are related to each other. right? So they want us to go ahead and to list the objects from least to greatest density, and then tell us which objects are more dense and less dense than water, right? So we're going to go ahead and we're going to kind of look at this equation again. So if you have a high density, you're going to have a steep slope, because obviously you're going to have a very high rise over run. And this means that it's going to be more dense, and more dense stuff tends to sink, right? If you have a low density, it is going to have like a smaller slope, and it is going to go ahead and it's going to float. So these things tend to float. So that is how those relationships work. So these two objects, G and H, right? These G and H, it has low density. And that is because they have a small slope. On the other hand, right, you can go ahead and you can look at water, right? And we have water in the middle, right? And that one has like a medium um, density going right here. This one right here is going to tend to have a higher slope. So because it has a higher slope, it also has a higher density. So if I'm going to go ahead and if I'm going to list these objects from least to greatest, right, I'm going to say that's going to be H, G, water, F, and then E, right? The objects that are more dense than water are going to be F and E. The things that are less dense than water are going to be G and H. So that is pretty much what you need to know about like this density graphs and making sure that you're able to go ahead and to identify them. A couple of other things, just be aware that you do need to know volume equations. So a volume of a cube. So if you were to go ahead and if you were to draw a cube, I'm sorry, it's not the greatest cube on earth, but it's a cube. Don't forget that for a volume of a cube, you're going to go length, oopsies, that's not length. You're going to go length times width times height. So this is going to be your height, this is going to be your length, and that's going to be your width. So you have to make sure that you are able to multiply those things together. If you have a sphere, it's usually it's like a 2 pi r deal, so just kind of keep those things in mind, that those are different things that you can go ahead and use to go ahead and to find volume. So don't forget that for volume, it's length times width times height. But other than that, I just want to tell you guys good luck on your test, and if you have any questions, please feel free to contact me and I will help you out. Okay, have a nice day.